What's up, everybody? Welcome to TeslaFix. Today we have a special episode about the Tesla Bot again, because we had a recent video that was not leaked but published by Tesla actually, about the advantages that Tesla did all those months. We are witnessing now the different things Tesla Bot can do. It was a video about sorting things. And for that, I have again a special expert, a certain aerospace engineer who also works in the field of robotics right now. So let's see who it is.
Welcome to TeslaFix. Make sure to subscribe and like this episode.
So hello again, Scott. Of course, when we talk about the Tesla Bot, we have to have you on. You're the Tesla community favorite aerospace engineer for talking about the Tesla Bot, because of course you got a background in robotics and you work there, you have your own company and doing a lot of interesting stuff there. So yeah, Scott, maybe you can tell our audience what you're up to right now, and then we're gonna start the episode.
Yeah, so guten Tag, danke für die Einladung.
Kein Problem.
So we've been down the road a few times on here with Jan, and glad to be back. And yeah, my background was in aerospace engineering, and then when I graduated, somehow I fell into robotics after that. So, and I've been doing that for about 4 decades. And I've been looking at a variety of different robots because we simulate the robots. The problem with robots has always been not building them necessarily, but actually programming them to work and then being able to come up with methods to make it easier, especially for people to do it in a virtual world or offline. So that's what I've been doing for about 4 decades now, and it's been kind of brand agnostic. So the idea is we look at all the manufacturers out there, all the different types, all the different kinematic types. So when the Tesla Bot came along, we're like, yeah, I've seen things like this before, because we've created also human beings that have to work in the factory setting as well. So I already understood the kinematics of the human arm, of how you would put it onto a torso, how you would potentially make it walk and everything else. So yeah, when the Tesla Bot was there, it's like, oh, this is going to be pretty fun to go through and analyze how it's going to work, what kind of tasks it's going to do. Is it a fantasy, this idea of having a humanoid robot? You know, couldn't you just, if you're going to automate it, isn't there other kinds of automation could in there and do the same thing? And so those are all really, really valid questions. And, you know, we'll try to address some of those today.
Yeah, awesome. And of course, you went to the mall.
You know, just outside of Disney World, Central Florida. And the mall is known as the Florida Mall. So it's a pretty easy mall to remember. And we went to the Tesla shop there. And, you know, they put out the red carpet for us because it was the Tesla Owners Club of Florida arranged the event. And so we kind of flash mobbed them and went in there and talked about it. And then, of course, the night before is when this video comes out. So it was kind of timely to go with that event, because there were definitely a lot of questions about that. And it was a surprise, because we always sort of knew when we were expecting to see an Optimus video. It's like, oh, Investor Day. Pretty sure they're going to have was Optimus going to be up the stage? What are they going to have? Well, they're at least going to have a video. And shareholder meeting. Yeah, they're going to bring out Optimus, or, you know, they'll at least have a video of this. So you kind of knew they would be there. But this was just a bolt out of the blue. It's like, well, wait a minute. And maybe it makes sense, because would you do it during a Cybertruck event? No, it's about the Cybertruck. Or if they're going to do some sort of official Highland Model 3 unveiling kind of thing. Yeah. But everyone is expecting it towards AI Day 3, which looks like it won't be till the first quarter of next year. Okay. It's probably not going to be November. So maybe it was like, oh, there's a big kind of gap. And I think they did it for 2 reasons. One is that they probably really accomplished certain milestones that they wanted everyone to be aware of. And second, this is not a promotional video for Optimus. It's a recruiting video for Tesla AI. I mean, it was pretty clear from the tweet and everything else, is that they want to kind of get that excitement from everyone. And then I think there was like over 54 job postings that are all Optimus, you know, well, I think it says like Tesla Bot, Tesla, and in a variety of different areas. So it's very clear they're getting ready to hire a lot of people, not just for the bot development, but also looks like ramping up production, which I've also, on Herbert's channel the other night, it was like brainstorming something. And I think I have a pretty good idea. Well, I don't know if this is how they're going to do it, but I hope they seriously consider my harebrained scheme of what the bot factory should look like. But we'll get into that later. Yeah.
Yeah. We're gonna get into that, of course, as well. So for everyone, watch the Herbert video after this video, of course, again. And also, one thing, commercial for my channel here, because we already did a small tour before this airs. That's when you went there to the Tesla Bot itself. I'm gonna show the video here where you
This was a complete disaster because I didn't have any sort of equipment set up for it. My mic was horrible. It was these earbuds that were a really bad mic. And then there was all the noise around there.
Yeah.
And they were like vacuuming the Teslas to get ready to open up the showroom.
Yeah.
It was... So I was like, okay.
But still, you asked the hard question to TeslaBot, but there was still no comment from TeslaBot, sadly.
Yes.
Because maybe the language model still doesn't work for TeslaBot.
Yeah. The irony is, of course, I'm looking around, it's like, I don't have a microphone. So I just took a selfie stick and say, let's pretend this is a microphone. I'm going to go up and I'm going to ask Optimus a question. And he doesn't say anything. And we took a picture of that and we tweeted it out. It's like, I asked for his reaction to last night's video, and all I got was no comment. And I just thought that was just kind of a lame post that I put out there. And I get the first like from Elon Musk on that one. So I was like, what? Of all the snark and the other stuff I put out there, that's the one, he first at least noticed, I don't know, or liked.
Yeah, that's very funny. So if you want to watch that, I'm going to link it here as well. It's a small, brief episode, and don't mind the sound. It's a little bit janky because it was just with earbuds,
I learned my lesson. I tried using earbuds that just, the mic is up here, so they don't pick up. For some reason, mics don't like my voice. I think I'm just too deep. And so they won't pick it up. And it's better off getting a setup like this. It seems like things work a little bit better. And I had that in my bag and I completely forgot about it. It's like, I should have just put that thing in order. So my apologies to everyone who has to suffer through the horrible audio quality.
Yeah, but no worries. So that's why we have you as a follow-up interview here. Of course, I mean, I've planned to make this as well, but this was a super opportunity.
Disaster to you as well as your audience.
So no worries. So of course you were talking about, now let's get into the nitty and gritty here. We talk about this video. I'm gonna pull it up here, and maybe we can just talk over it a little bit. So
there's nothing to really talk over because it's just what you see down there. It's basically three parts. The first is self-calibration. So just pause for a second so I can explain what that is. Some people might be familiar with the term proprioception. That's basically sort of your body's sense of awareness and where it is. So that you can close your eyes and move your arms around and you kind of have an idea where they are in space. And you can do things like touch your nose with your eyes closed, everything else. Sometimes if you're lucky, with your eyes closed, maybe even get the fingers to touch. They come kind of close, and then I can kind of recalibrate to get that. And industrial robots have this thing, but they don't call it proprioception. They call it inverse and forward kinematics. So it basically means if you know the angles of the joints of your arm, you can calculate the Cartesian position. And vice versa, if you have a desired Cartesian position you need to go to, you can calculate the angles that you need and then just plug that into your control system to help move to those angles, and boom, your tool will be exactly where you want it to be. But in order for that to happen, you need to make sure you're properly calibrated. And typically what that means is that when you make anything, there's always manufacturing errors and everything else that goes on. A lot of those you have kind of under control. So hopefully the lengths of your arms and all those are exactly what you want those lengths to be. And then when you connect something together, hopefully it connects together the way you want and not at some strange angle. But the main thing is you get these actuators or motors that are spinning these joints around. And when you connect them in there, you don't know what the reference zero is. So what is the actual datum? So what are the values of my encoders where my arm is aligned in a particular way that we agree that encoder value means zero? And what's usually known as the joint zero positions is the largest source of error in any sort of robot. It's like easily 80% of the error. So that's the one everyone goes after. And once you get that, the rest of them are kind of minor and you can chase them if you want to. So when they build it, and the question is this like a one-time calibration they have to do when the robot is first assembled, or does it start to drift and change after a while? Because normally when an industrial robot is built, they put it out and they have these very expensive setups to measure the positions of the arms to create the signature file that then goes to the robot. And in theory, you would never have to do that again. Unless, of course, the robot needs to have maintenance or it's been hit or something like that. And then you may have to go and do a new calibration. So it may be that they figured out it was so darn easy to do with the built-in cameras and Optimus that they can go ahead and do it and then recalibrate it every now and then. Because there's going to be a certain amount of maintenance, I'm sure, that happens with this over time. That's like, oh, we need to go in and change out the hand for some reason. And rather than having to take it back to the factory, it'd be nice to be able to do it there. And there's no reason why they shouldn't be able to do it. You used to need very complicated setups to get the measurement you need, but now camera technology and the software behind it is so good, you can do it. And, the other way to look at this calibration is anyone that has a Tesla and then they want to use FSD, usually the first thing you have to do is calibrate the cameras. So you drive for a little bit and it tries to figure out where the cameras are, and you should never have to do it again. But sometimes you do, when the next software update comes up, they say, oh, please recalibrate the cameras. Or if over time things get kind of weird, like, oh, it's not following the lanes quite right, it might need a new camera calibrations because the cameras may have shifted or moved in their housings, or if someone bumped into you, obviously that's going to mess it up, or if they had to replace a camera. So those are the reasons you need to go out and kind of do this calibration. So your ideal model and your real model kind of in the real world model match very well, and the robot knows where it's going with pretty good accuracy. The other reason you want to do it is you would like to make sure every single Optimus is in agreement. So if you have an Optimus which has been trained to do a particular task and you want another one to do it, you should just be able to have them both do it with the same precision. But if their outputs are a little bit different, the way they've been trained, then the result could be that different optimi are going to behave different. So it's basically the way to make sure that they're uniform. And as you see, the way they do that is they track a lot of positions. They look for some landmarks. So the camera system is going out there. It's very much like, your camera is really pretty good at identifying a face or something like that, or maybe even a person's eyes to know to get rid of the red eye. So it's because it's looking for certain landmark features, and now it's looking for those landmark features and is able to identify where it knows it's supposed to be on the real Optimus, and then say, aha, based on these joint angles, it should be at this position in space. And then based on what the cameras are seeing, it might say, oh, you're off a little bit here. And it gets enough of that data and it can crunch on it and basically go through and do some fitting to find out what are the right encoder position offsets to minimize that error, to get it down to millimeter or sub-millimeter. It depends on how accurate that reading is going to be, but it's going to be the error order of about 1 millimeter probably, and that'll be good enough.
Yeah, and also what you notice is that the movement, of course, is a program that like a adjustment movement, a special one that you always know when that's off, because they have it digitally or virtually. They know that, okay, this has to be the position of the hand, and if that's off with the measurements now with the camera, they know, okay, they have to move it up a bit, or here's the position, and they have to, then they can adjust those encoders controlling the hand movement, for example.
And usually you will have the robot go through a certain sequence of exercises that are well known to get you what you want. Part of it is that you don't want to be too methodical about it. Actually, you want to be a little bit random about where those positions are to get rid of any sort of biases, but you could have something like that. Of course, the funny thing is to say, well, what we're going to do is you want to move your hand over here so it's in our field of view. And that's the whole idea, is move it around so we can get a really good image and not off peripherally. But, if your joint zeros are so far off, you can say, all right, put your hand, in front of your eyes, and you imagine, like, put it here, you can see it. And you tell it to do it, and it goes back like this. You're like, where the heck's the hand? Because, your offsets down here and the shoulder joints could be just so far off. So it would be kind of humorous to see if they kind of go around and begin to realize, man, that's a really bad offset, and we've got to correct that. But I have a feeling the model is sort of close to where it's going to be. It's just that you want to refine it. So hopefully it's only off by a couple of centimeters and not off by a meter.
Yeah, and also what I found very interesting, if you look at the footage of the Tesla bot that was published before this video, we had this field test or test here that you can see. Here's the virtual Tesla bot on the right here, and they have this VR suit or AR suit, or how you call it, and to control the robot. And I found that very interesting, those similarities to also the sorting thing. Here they are recording it. That's more of a simulation. They try to record what the human does, how the bot should do that. So they train the movement of the human to the robot with this. And I found it very interesting because we've seen because in the video, of course, the Tesla bot sorts things, and I found that very interesting to see again.
This is part of the way that they trained it. And I think we have a better idea of how they trained it now. There could be all sorts of sources. People talk about simulation and everything else. If you look at what he's wearing in his head, that's not like some VR setup they have. That's the actual camera from inside the head of Optimus. Yeah. It's the exact same camera setup. If you look at that big heavy backpack, what the heck is that? Well, that's the FSD computer and everything else. So basically he has the entire Optimus setup. And so Optimus contains two parts, the vision system, which is looking at what's going on, and then the part that's able to manipulate. So you can think of those two systems. And if you remember, the way they're talking about it working now, the end-to-end, vision in, joint encoders out. So what they're probably doing is that they are taking his hand movements right there, and they're kind of going back through a computer and saying that, okay, taking what his fingers are doing and the position we have of the hand, we are moving a virtual Optimus right now. So we are calculating what the encoder value should be if he was Optimus. Yeah. And now this is what Optimus is going to be seeing. So what you're doing is you're training the vision to be of what it sees to what the joint output should be. And there's a very good tweet out there everyone should look at from Dr. Jim Fan, that he goes through a bunch of these different steps where he tries to explain it and says it's very similar to what Google was doing with the RT1 paper that came out about a month ago, explaining the tokenization of everything here. So you have like the vision in, and it actually creates an output token, almost like what you see in a large language model that allows the system to sort of understand what's going on. And that's what Tesla has been saying, vision in, joint values out. And now I kind of understand what the secret sauce is that his inputs are going to that virtual model and then being correlated with what that vision system is seeing. Yeah.
So this was the tweet right here. Is it that?
Yes, exactly. That is a very good one. And you should go through it. And again, he's an outsider, but let's just say he's very knowledgeable in this field. And he came up with some very good points. And there was like a 0.5 in there that really crystallized things to me. So hopefully everyone in your audience understands what the whole idea of the transformer is. And the idea of the transformer is a way of making any sort of AI model, typically a large language model, sort of remember the context of a conversation that's going on. So it gives it a certain amount of sort of short-term memory to understand what we're talking about. And it used to be a problem that these language models would forget what they were talking about in the middle of a sentence. So you'd start a sentence, and then by the time you get to the end of it, it didn't remember what the subject of the sentence was because it could not keep enough tokens in there. And the transformers was a way of allowing you to keep attention to the things that are important. And I think that was referred to as the famous paper, attention is all you need. So what's the important things? And he's trying to figure out, well, how do you use a transformer in this kind of situation where it's sort of video in and out? And that is that you tokenize everything and putting the above, putting the above in there. And so it really comes down, the next frame from the table is fed back into the transformer. So it knows the consequences of its action. Yeah, that's very important. That is really good because the whole idea is that when you're writing a sentence, the grammar and everything has to make sense with the words that kind of came before it. You can't complete the sentence without kind of knowing the stuff that came before it. Normally, when you're moving, like when the car is driving down the street, it doesn't care where it came from. It just cares about what's right in front of it. Yeah, exactly. So it almost has this amnesia of, how did I even get here? It doesn't matter how I got here. So you can kind of look at a path that way and say, it doesn't matter. But in this case, it's a little bit different. We're saying, well, it may not be important where I was like half an hour ago, but where I was 10 seconds ago may be very important, especially when you're looking at doing a particular action. So in this case, it's like, I'm going for the blue block. And so the focus and the attention is on the blue block and everything is sort of calculated to do it. But suddenly that blue block moves. Okay, what am I supposed to do now that the blue block moves? Well, if you don't remember that the whole goal of what you were doing was to pick up the blue block, you're not going to change. You're probably just going to go to where it originally was and then suddenly discover, hey, it's not there right now. So this is the whole idea, is for it to sort of understand the consequences of its moves and to better understand the context of the situation. So here, we see it's very easy for, in that case, it's doing the self-correction and made a mistake. But normally it's just finding parts and picking them up without any issue. Now, when a human comes in and starts to play keep away, it has to now adapt, and it adapts very, very quickly. So it's really very nice in how it's able to kind of, and sometimes it goes to the new position that he pushed the block, and others just says, no, I'm not interested in that one. I'll go for the other, like it did right there.
Yeah.
It just decided this other green, it doesn't matter the order I put them in. The only thing is I need to get all the greens over there. And if you're making it hard for me to get one green, I'll go for the one that's easier. Yeah. And the other thing is, like a human, it may not necessarily be really picky about where it puts it on the tray, just so long as it's on the tray, which is why they bump into each other. And you have that kind of awkwardness there where the fingers get caught and everything else. And that happens to us all the time. And maybe eventually it'll figure out to not do that so often, to do a better way of that pattern sorting. But right now, it's probably just trying to minimize the amount of movement it can have, which is why they keep on bumping into each other. Yeah. And its target is like the tray. It's not the center of the tray. It just appears to be somewhere in the tray, which is like almost the closest to where the pickup was. So the ones that are further or closer towards him tend to go closer in that part of the tray, and further out, they go somewhere else.
Yeah, that makes sense. He just puts it, like his task was just,
now something John Gibbs and I talked about yesterday that would be interesting is that one of my concerns here is Asimov's 3 laws of robotics, which are you familiar with those? It's basically that, a robot will not cause any harm to a human, a robot won't cause harm to itself. And then the third one is like, it won't cause harm unless it somehow violates the first one. So in other words, if what it's going to do, it doesn't want to hurt itself, but if it tries to protect itself and ends up hurting a human, then it's like, oh, okay. And then the 0th one, which came later, is that the robot should cause no harm to humanity. Okay.
Yeah,
but the first thing is cause no harm to a human. And in this case, you've got to wonder, is it aware that human hand is there and does not strike it and bump into it, and what precautions to make? It's not going there. Now, at the same time, the human is being very careful not to interact with Optimus unnecessarily. But I wonder how much it's trying to avoid that situation and whether it's programmed in. And so when you play this game of keep away, part of it is blocking the view of the block, like we would to kind of annoy someone, and so it can't get to it because the human hand, even if it's aware it's there. So first, is it aware of persistence? Does it know it's still there? It's just hidden. And would it do something that maybe you and I would do, is like push his hand out of the way and get it, because you get kind of annoyed with this game that you're playing. But you see, Optimus is very patient because he does not have any sort of emotion. He'll just kind of do it and keep doing it, and he's not being annoyed like we would. Hopefully, you just don't know if that, because large language models after a while do show a temper. So hopefully Optimus doesn't. But what would be interesting is to actually, rather than have a human there, have Optimus playing keep away with the other Optimus. Yeah. And sort of see what's going on as a game. And there have been these AI games out there that are done in simulations of keep away. I don't know if you've seen or it's called hide and seek. And that was really interesting, that they have these little agents that are running around trying to, that some of them are trying to hide, that the other ones can't find it. And so you have these two agents going back and forth, and how them just becoming very creative, of course, after millions and millions of iterations. And in a sense,
it was a simulation, right? Was it a simulation?
Yeah, it's a simulation. It's a simulation.
Yeah, of course. Yeah, I've seen that with those blue and red figurines that run around.
And it was 2-minute papers. So you just look up in 2-minute papers, and it's there. And it's just sort of fascinating to see what they came up with and how they kind of learned to cheat and do everything else because, to use maybe physics on their side or create new. But it was really fascinating. And John and I were wondering, it's like, well, if you have the two Optimus there, it would just like be this endless loop, because there's no way one of them, I guess, unless one of them just decides, I'm going to pull them over here out of the other one's reach, then they're going to have around where they're going to start to wrestle for them or something like that. But if you're just constantly moving them around like that, it's almost impossible for any one of them to, if one of them is to get them all out of it and the other one is to like get them all in, how they kind of compete, and whether they learn to trick one another. If that's the goal, do they find some other particular way? And the one thing I was thinking is like, if it was going to cheat, the cheating was like, one of them is like, just does enough effort to make sure the other one never quite wins, and make sure the other one has to like work really hard for every single like point that it's getting, whatever, and just be really lazy until the other one's battery wears out. Like, okay, now I won. And so that would be the hacker to cheat and to see, is Optimus going to be smart enough to sort of figure something like that out? Yeah. Or Optimus finds out, wait a second, here's an interesting button on the top. Maybe I can press that one. Now, just disable it. So as we see, That's usually called the emergency e-stop button. Okay. So the emergency stop button. I feel uncomfortable calling it the kill switch. So we'll just call it the e-stop, which is typical in automation everywhere. You'll even see them on escalators in shopping malls. You'll go up there, you'll see the red button that you just like hit that thing and it will stop the movement of it.
Yeah.
And that's in the back. And everyone keeps on saying, well, why doesn't Optimus have 360 vision? You know, it has all these other cameras. It has a kind of a wide field, but it can't see all the way behind it. Why not? And it's like, so he can't see you sneaking up from behind him to try to turn off the e-stop button. That's why. Yeah. It's purely a safety concern.
Oh, man. Yeah. Yeah, of course, but it makes sense that hopefully when you do a simulation like that, running it through the weekend, everybody's out of the office. Suddenly, TeslaBot thinks, wait a second, I could arm myself and build weapons to defend myself to get rid of the other TeslaBot, and then maybe this is the dawn of humanity and the Armageddon hits.
Right. It's just going to have to run out with a really long extension cord. You know, it's like it's going to figure, I get that 8-hour battery life problem.
Yeah. That's interesting scenarios to think about. But yeah, it makes absolute sense, and I found it very astonishing, the progress. And for me, of course, was the scene where the brick fell over. I mean, this is also very spectacular, but the brick falling over was a thing I really thought,
understands.
It understand. Oh, this fell over and it corrected itself, and I think this is so interesting to see. I mean, it's still very slow, of course. This was sped up 1.5 times and sometimes even 2 times in the video, but I think it's a reasonable speed actually for the bot actually, and this is just the test phase. I mean, this could be faster along the line, of course, but at first it makes sense to have it slower, that it can process everything.
Yeah, and I wonder if that was kind of an emergent behavior that they weren't expecting, that maybe it was taught that they're supposed to be in a certain orientation, and then it kind of looked down and noticed that something was not the right orientation and went there and did it. Now, I don't know if that was just random chance, the way it kind of picked it up, but that's kind of the way you and I would have done it. Because if you thought about it, you see how it kind of picked it from the side because it knew it had to flip it over. If you and I had kind of picked it up more from what was like the top at that point and tried to do that same twisting motion, it probably would have been beyond the limits of our wrist action. It would have been a bit uncomfortable or hard. So it seemed like it knew, for that action I have to do, it's a lot easier for me to grab it from there to be able to get it upright.
Yeah, and what really struck or made it for me was the way just the fingers turned it. It was very subtle, subtle movement, very very precise movement here.
There may be something interesting here. Is a few years ago, OpenAI did the Rubik's Cube hand. So they have a hand that's like way more nimble. It's got way more degrees of freedom. And it was taught through millions and millions of iterations of simulation how to do the Rubik's Cube. And then eventually they brought it to the mechanical one. And they were surprised after that, some of the tricks it learned, because now it had like real world physics where the friction and everything else was realistic, that it picked up some tricks. In other words, some emergence that they did not anticipate to be in there. And you can sort of see that sometimes that it understood how to do like a subtle little shimmy of the hand to get the cube to move around the way it wanted so it could get to the next one. And it could be after a while it learns this. And Jeff Lutz has made this point also the other day on Herbert's channel. It was really quite interesting where he's talking about that he's an industrial engineer and you know, you'll be going down the line and you'll bring in all the workers to do it. And everyone will sort of figure out how to do it, but there'll always be a couple that will just know a slightly better way or an improvement upon the process that you did not expect. And then eventually you kind of grab that and you try to teach it to the others. And that's something my father did, is like, he was always supposed to find who was the star performer and analyze them. And he would ask them what was they're doing. They had no idea. They just, to them, it seemed natural. They could not explain it and they couldn't teach it to anyone else, which was the frustration because sometimes the people who are really good at something are the worst teachers. So it was he was supposed to go out there and try to analyze it to find out what is the trick that they're doing, you know, be able to put it down on a piece of paper and say, this is how we now train people going forward. And so a lot of times that improvement, you want to then disseminate through the rest of the organization so you can get that extra second that you've been looking for along that line. And he's just thinking, it's like, oh yeah, once these Optimists get out there, we're going to teach them a particular way. And then they're just going to iterate on it. and they're going to get a little bit better, and they're going to improve and improve and improve. And so that was like one of the aspects I hadn't sort of thought about, that it's not that we're going to suddenly, crank it up to 11 on Optimus or make them run a little bit faster, or we get, some batteries a little bit better so they can run a little bit faster. It's really going to come down to coming up with more efficient movements. And so you are going to want to come up with some sort of internal, cost functions, or call them KPIs or something like that, that it begins to learn, that it understands this is a better way to be able to do the whole operation. And it might be a little bit different than some of the cheats that humans do. So what human operators have learned is that they're on a very strict budget of like, they have to get something done in less than a minute, and they get a certain amount done. And they might have like 10, 15 seconds to themselves as like a little break to do something. But a lot of tasks, what they're doing means collecting an item from over here, another item from over there, and then like putting it on there and just keep on doing that on repeat. And then they start to get clever. And it's like, why am I picking up one item? Why don't I pick up like 3 or 4 of them and cache them locally? Another 3 or 4. And so the next time it comes around, I can just go pop, 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 save myself a little time and energy. That might be good for Optimus because you don't want the batteries to wear down. But at the same time, they're doing it in an unconventional way that is more at service to the way the human is doing, because the human is trying to get a breather, or get enough time that if they have to take a quick break and come back, they can very quickly make up for whatever lost time that they had there. But the Optimus may have a completely different kind of rule book on the reasons why it wants to optimize something that we can't see, that we wouldn't be able to do as a human. That will emerge.
Maybe even the longer time horizon, for example, that it just can say, I can do that at 3 o'clock at night because then less workers are around, or something like this. Or when the bots swap, because they can have swarm intelligence in comparison to a human.
Oh yeah,
real swarm intelligence.
I'll get into like my crazy idea that it's just going to change. I mean, the whole idea of how we organize labor in the factory is based around a very human-centric kind of behavior model in what humans can do and the best way to get efficiency out of them. And that's going to be completely orthogonal to the way you would probably be able to do it with the Tesla bot, which means the rules are completely changed. And I'm not even sure I know what the new rules are. I just know, okay, in Germany, you're well aware of this thing called, Industry 4.0, which was like the best branding Germany ever did. I mean, it was just, they actually came up with something and attracted a lot of attention. And basically, they see it as the 4th industrial revolution of the changing. And a lot of that was really around the idea of the Internet of Things, of being able to measure more things in the factory, to understand it, to be able to help organize all the stuff. But I really think the coming of the bots is going to push it to, like, you can almost call it Industry 5.0. 5.0, yeah. So that's because they're going to be more self-organizing kind of things, which we'll get into a little bit. We'll finish this video and off the others, and then everyone's going to have to stick around to the end if you want to hear my new ideas.
Great cliffhanger. So okay, maybe we go back to the sorting thing here. I mean, you've said it. It's interesting. Like you said, you also said something about the correction of the language model that's behind that. We've talked about that with the tweet. As far as I could understand, that it can adjust, it has to know, it has to remember where it was, so it can follow through. You've mentioned the example of FSD, where it just moves along and doesn't even know, how did I get here? So the memory, in that sense, has to be a new input to a loop, more or less like a loop. Okay, I know where I was, I'm here, and now it's going on and on. And
then
also,
once it completes that task, it doesn't really care about it. It just kind of moves on to the next one.
Exactly.
And the other things about is there's like no hesitation when it decides that it has to move or change somewhere else. So the decision-making ability is amazing, that it very rapidly changes. And I'm not surprised, because you think about it, if you look at the FSD analogy, you're driving down the road and it has a clear goal in mind. It needs to make it up to some other destination, and it's going to be sticking in this lane, and it's obeying the speed limit.
And do not
suddenly
crash.
A car veers into your lane, and it knows immediately what to do to prevent that and get around and get back onto its goal. So it's the same thing that's happening, which is why, it is version 12 in there making these same decisions. They've just been able to figure out how to kind of repurpose it for that but it's almost the same architecture, the same decision making. And you see how rapidly it's just able to make that change. And remember, the FSD computer on board, I think, is using less than 100 watts in your car, and there's 2 socks in there. So it's able to make, your Tesla driving around is able to do it in less than 100 watts. And so it's sort of the same thing here, that because it's an inference engine, it's just super fast to be able to make that decision. And then it moves to the next. The other that everyone noticed, I noticed it right away. And as I was seeing it, everyone else this week, James Damo was talking about it. A lot of other people in this field, is just the whole body movement that's going just on there. Everything is so graceful. Now everyone talks about, well, wait a minute. The left hand is sitting there, not doing anything. And why not? I'm not quite sure why. There could be a couple. It's like, it's not really needed. You could say, well, maybe it could be. You could be getting in there. Or maybe all the video input it was getting of just people who are right-handed and there wasn't any left-handed input. The other reason why the arm might just be sitting there kind of limp is to put it in any other position would require excess power. So it's almost like a power saving mode right there. But the rest of the body you see is moving around because it's very important to the overall balance and what's sort of needed for natural movement. So whenever you move an arm,
hip, for example, the hip or the torso.
So part of it is balance. And the other part of it is sometimes you literally have to lean into something to get the reach that you need, because it would have been straining way too much. So it's a lot better to go ahead and lean a little bit forward. So all of that is moving in a very natural way. So it's the neural network, which is telling what the torso and the pelvis and the legs should be doing. It's not some heuristic algorithm. It's really figured that out. And that's why in the next section, you're able to see that incredible balance, because it has full body control and full body awareness. It's not a collection of 5 limbs or 4 limbs in this case, because the head doesn't count as one anymore. But it really is, everything is aware of itself as a whole. So it's a very holistic approach. This did not surprise me at all. I didn't know what we were going to see, but I knew we were going to see something pretty cool when they showed what the controller could do back when the leg came down, not breaking the egg. So if
we have that
remember
as well.
From I think it was the shareholder meeting where they talked about the torque control. So it could really change its decision logic, in an instant. So it's wanting to tap the floor there, and then comes down and it feels the egg and stops quick enough to not break the egg. So torque motor control is really something else there. And now look at that. It's just like, oh, that's where the floor is. I'm going to just stop right now. So that means really rapid response, extremely rapid response in the system. And that carries over to why they're able to do these yoga poses. And again, the holistic approach, the whole body is sort of aware of where it is. So the very first pose it does is very interesting because he was trying to get that balance. So the one before this. And at the very end, you just see how it rocked forward? So it stretches out, locks in place, and now moves a little bit forward. Part of the reason for doing that is I have a feeling the center of pressure is over the heel, and it wants to get the center of pressure between the heel and the toes. So that's a much better way of being able to do it. So it just sort of like, let's rotate a little bit forward there just to kind of correct it, with everything else being able to hold that straight.
Yeah, and then it just stops, really.
Just stops, just able to hold that.
Yeah.
It would be, now, normally when the motors stop, they don't like just stop. There's still usually current going through there to be able to hold the resistance against gravity and everything else. Some of them may have I notice there's a clutch in there. I don't think there's necessarily a brake, but I have a feeling they're still taking a little bit of power. Now, an industrial robot, when it's holding itself fixed in some location, especially with a heavy load, you might think it's locked in place. Some of them do have braking now for this reason. In the old days, they didn't. You go out there and you could just hear those motors humming and everything going through there. And it really is like, when you're holding out a dumbbell like this in yourself, and your muscles just start, and you start seeing that in an industrial robot. It's like, and which is why now they actually have like brakes in those things, because they want to have like a power saving, that when the robot's in what they call the home position, they don't want to, if they power it off in the home position with a heavy payload, it might just go down like this. Like, no, they don't want that. They want it up there. So it's sitting there waiting, wasting electricity. So and then sometimes you'll hear a click, and then it puts the brakes on, and then you'll hear an unlocking, and then it'll be able to move ahead. But I don't think Optimus has that necessarily. So but you're not seeing any vibration. A lot of times, some control systems, when it's trying to hold a position like that, you see a little bit of vibrating. So it's great that it's just able to kind of hold the other positions while it rocks forward.
Yeah, it rocks a little bit forward and backwards, but then it really suddenly, it's very subtle.
That was the intent. I think while it was stretching out, you're going to be expecting that. I mean, that's just kind of physics playing out and how everything's moving back. And you're not balancing on your tippy toes, so it's not that critical. You got the whole bottom of your foot to be able to keep you that balance. The thing is, the weight is shifted such that it's more on the heel. That's what we would call your center of pressure. And you just want to move the center of pressure a little bit forward. So the control system is probably deciding rock forward just a bit.
Yeah.
And let's get that center of gravity more between there. Because, I think airline pilots understand on an aircraft, there's something called the static of margin, where, in between those things, your airplane is, the control system is stable. But just because you're in between the minimum and maximum, if you're right at one of them, just a little bump one way or the other, and suddenly you're unstable. So everyone likes to keep, in the middle of the static margin. And that's the same thing. Keep your center of gravity over the center of your foot, and you're less likely to tip over. And then the last move is very nice because of the side profile that you may not quite be seeing it here. But in order to do that move, the ankle has to bend a little bit to, I guess, to our right, to its left. So you see the leg is not straight up. That means the ankle and the foot has to have that degree of freedom. That's why there's 2 degrees of freedom on the foot. One, because you'll be walking on uneven surfaces or surfaces that aren't flat to be able to handle that. But in this case, if you want to be able to balance on one foot, that's very good. And, this means a lot for carrying heavy loads, because Optimus is going to be carrying things that it seems to have very good balance, extremely good balance. And it's because it's using its entire body. The last thing I'd like to say about this is that if you've read Walter Isaacson's book about the origins of Optimus, and you just remember, it's not even September 30th yet. So 1 year ago on September 30th is when we first saw Bumblebee walk. That thing came out on stage and it still couldn't walk. So they had just started to figure out how to walk a few months before. So it hasn't even been 2 years. So a little bit over 2 years ago, they announced the project. They get in, a couple of days later to say, oh, Elon wants us to build a bot. What do we do now? And evidently it was like just volunteers. They didn't really have a full team. So anyone that was interested in the project could just show up and start working on it. So that meant you had these people that probably knew absolutely nothing about building a human robot and walking and kinematics. Now, they probably knew a lot of different things, but in some ways, it's like, wow, they're way out of their element. And some of the early questions that were going on were kind of very naive. And it's like, well, these guys were like really biomechanics. And I could tell there was not one biomechanist in there. Because when you see the actuators that came out, they talked about things like shoulder roll, shoulder pitch, shoulder yaw. That's something a roboticist would talk about. If they had one biomechanicist, it's like, no, that's abduction, okay? We got pronation in there, and like rotation and flexion, and like all these other terms that you just don't understand. They'd be throwing all kinds of Latin terms in there. And it's like, it was really interesting. It was like, wow, they're using that standard terminology for everything. And it's because there wasn't a biomechanicist in there, which maybe was a good thing. I don't know. And then they barely learned to get the robot to walk, to the point that if it moved its head, it fell over. I mean, just think about being that clumsy that you turn your head and you lose your balance. And that's when Elon says, it doesn't need it. We've got the cameras. Why do we put that there? Get rid of it. To this point now, it's like, yeah, you could have the head bobbing around now and it's not going to be any problem, but I don't think they really need that access. That would be a waste. So they've gone from, it looks like, almost like the gang that couldn't shoot straight, or the bad news bears, whatever analogy you want to have, they started to do it and everyone ridiculing them. It's like, oh, you won't do it. All these other companies, like decades and decades, they've been working on it. Walking is really,
Boston
really,
Dynamics
really hard.
can do parkour. Yeah.
And it's like Boston Dynamics is way ahead. And I agree. Boston Dynamics was way ahead. And what's happening is Tesla, they're running this marathon and now they're hearing the pitter patter of these steps of Optimus coming running up. So maybe Tesla is not in first place. But boy, whoever the leader is, and I don't know who the leader is, should be staying up late at night and worrying about it, because this is just showing extremely fast progress.
Yeah,
and
absolutely.
The fact that they are using AI in lots of their control system is what's allowing this. So their secret sauce, I think in the end is probably, just that FSD chip and Dojo.
Yeah. And I think it's important for the viewer. I mean, some of you viewers here that are here are very tech guys, pretty deep also into those topics as well. But there might be some people who are more on the surface, like me. I'm more of a designer. I'm not an engineer in that sense, and so I don't really know much about the things happening below the surface there. But Boston Dynamics has like the robots have a pre-prepared path that they follow. They cut those videos together out of huge hours of material, of course, because the bot falls over, and they also made like a behind the scenes where you could really see, like, to get to the point where it does it perfect. I mean, it's still astonishing what they accomplished. I don't want to just it's absolutely amazing, but still they have a simulation, a path. They have a computer there to really figure it out. And FSD, the FSD computer here is totally a game changer, because it's the neural net can train itself, and this is really much the thing. It makes the own simulation by itself. And like we said in the last episode, we talked about the robot. I find this analogy so cool that the Tesla bot gets to the charging station and dreams about the things that it's gonna do. But of course, it can have an uplink life while it's doing things, so it doesn't have to dream. But still, I like this analogy of the bot training in the simulation, and this works. And then in reality, you can go on, and it learns from every way. Yeah. And that's just absolutely crazy, just with computing power. And so the sky is the limit there of training the body that's in, like, this. It's not a consciousness, but this artificial intelligence working there, making the movements, is inside of this body. And then you just have to upgrade the body, and then it's gonna improve and improve. So the improvement Tesla bot will do is like exponential. I can really see it. Yeah. So this is pretty crazy. Yeah.
And I'm not surprised about that, because at first everyone was like, walking is really hard. You had, I think, Honda first doing it with the asimo project, and they finally dropped it, I think 2017 or 18, somewhere around there. And it'd been like a 30-year program, and one of the first walking bots. Took them a long time because they were dealing with these antiquated computers. They didn't have like a full understanding of it. Others that were doing it starting, over a decade ago, where they maybe didn't have all the tools. And this is sort of typical, because do you remember when the Segway came out? Yeah. The Segway was just kind of amazing. It's what's known as almost, the reverse pendulum problem, where the inverted pendulum problem, this idea of being able to balance a pendulum sort of upside down. And that's what the Segway was doing, because it had a really good control system. And there was like a lot of R&D and everything else in there. And it just sounded like, man, it's like a moonshot. It'd be really hard for anyone to do. It's like, no, cat's out of the bag, because now you have all these control systems. You get people who are going out, starting up their own companies. These things are starting to be taught in universities. And then you have a bunch of people. And now look around. Like all these scooters and all these other things, they're basically doing the same thing that Segway did. And they brought the price down. They've been able to figure it out on their own. The same also with drones and quadcopters. Yeah. It's like everyone can just start building their own, because everyone understands how to do that. So the walking problem has been solved, and there's enough people out there that know how to do it. There's enough papers, there's enough university researchers that you can go ahead and find out the information that you need to know to be able to do that. Then you just throw in the fact that you have the AI, which I think was the missing link, because everyone was trying to write the code, the heuristic code. And it turns out you don't need, with the AI, just train the net, and the net will do all that heavy lifting for you in getting it to work. That is why Tesla has been able to leapfrog so many, because they do not have to write what appears to be like many, many man years or decade years of computer code. It's just almost going to solve itself. So you have the right foundation, everything just starts to go. And that's why you're seeing things going very, very fast. And will continue to go very, very fast.
Yeah, and if you compare it here to the Asimo robot, what's the difference here? Because the Asimo bot also walks around, picks up stuff, but these are pre-planned routes, right?
Yes.
Those are coded, hard-coded.
Yes. And the main thing is so they're telling it sort of where to go. It might have a little bit ability to do some object avoidance. But the main thing is the control system is making sure it doesn't fall down. And it's it's low. It's got a very low center of gravity. and you'll notice that when it walks, it almost, it never really takes one foot off. Yeah. So it's walking in such a way that you're not going to lose its balance, almost like what a toddler would do. So the knees are very bent. It wasn't a bad program. It's a shame they kind of gave up on it. So, I mean, that there is getting impressive, being able to hop on his feet. So eventually they're being able to do that, which is quite good. I'm not really sure why I think the reason they dropped it is it just sort of ended up being more of a party trick than anything else. It was something that brought a lot of good attention to Honda. It was great at a lot of conferences and everything else, but it's not like they really found an application use case for it.
So sad. It was such a good program.
I don't know why they kind of gave up. Probably because they just said, "Oh, we're the laughing stock." Everyone's like, "Oh, Honda's working on that silly little humanoid robot." And they probably just kind of gave up, only to realize that that's the hot new thing right now. Everyone wants to do it. So maybe the directors there are saying, "Wait a minute, maybe we should reconsider." Because I mean, look at the fingers, they have all the joints in the fingers, and I was trying to think, are they the same length or are they different lengths there? They might be the same length, but they have more knuckles in there than you do an Optimus. Oh, they already had quite a lot.
Yeah, they had a lot of things figured out, and if they had the artificial intelligence component or the FSD computer, I mean,
it would help.
Yeah,
it would help because they were sitting there really concerned. I mean, you could see in that force diagram in there, they're trying to understand everything about how to teach to pick certain objects and all that, not realizing that machine learning will do all that hard work for you.
Yeah. Interesting. Yeah, interesting to compare these two as well. I mean, it's because Asimo was such a huge project in that sense. Then it came Boston Dynamics at first with those I could call them like horse robots that are just walking
the quadrupeds.
To walk in different terrain for the military, of course. The Boston Dynamics has a lot of military applications here, but then we saw the Boston Dynamics robot, humanoid robot, and this totally changed the game. I mean, this was such astonishing and hyped, but maybe we can talk about something else here now, more about the economics again a little bit, because that's the main issue with Boston Dynamics, because they have, of course, research funding, a lot of research funding, but then they also had money problems, and they were went through different hands.
It went to Google, and then it came over to Hyundai. And then it was like, okay, you've got to start making money here.
Yeah.
And there really wasn't, they're making some money on Spot. I mean, that's a very good application, and they've found a really good market, and they're integrating the sensors in there. It's a pretty good product. And then, Atlas, I don't think they've really found an application for it. It's one of those kind of, I wouldn't call it necessarily a vanity project, but it's one of those things that sort of is the face of it that brings attention to it. But now they've come up with a couple of solutions look very much like a traditional robotic solution, which is actually very clever. It's like some unpacking of boxes out of trucks and stuff. Yeah,
those ostrich robots, right? Those with the two wheels.
Well, they had that ostrich robot for a while, and it turned out it wasn't such a good idea. It was the one that was on wheels. The thing is, it literally had too big of a footprint, and it had this big counterbalancers out there, and it was. Yeah. It was cool. It was interesting what they could do with the controller. The problem is the arm was just constantly moving around a lot, and it wasn't fast enough, because when it got over there, it had such a hard time settling down to pick up something.
To stop,
and all
of course.
That
to
slowed it down.
balance the whole load and everything. I can imagine that. This
so then they came up with it's a kind of a traditional one, but a little bit different. It seems like to me it has like two elbows in it, which is surprising for the reach. I think that's the one that's called Stretch, and it has a nice mobile platform. So, it's a wheeled platform, but smaller wheels, really big battery pack, low center of gravity. It just stays there and is able to go in the back of a truck, will drag a gravity feed conveyor along with it. And then it just starts rolling boxes off of that thing. Yeah. And it's taking over the jobs that typically people would do, but without a humanoid bot form. And so it is absolutely an excellent design. It's just, it's not a humanoid bot though, but I really, from the industrial robot standpoint, I really like that design that they came up with. and how it's able to move around and pick up all the boxes. And they've counted that worldwide every year there's something like 1 trillion boxes that had to be picked up and shipped around, moving. And this here is them basically showing off that what they can do with their controllers. The fact that these two bots are able to dance and understand each other, and then one of them is going to do a circle while holding one of them straight, its end of arm or in the air. You see that? How it's kind of going around, whether its tool point is staying fixed. I mean, that is just showing off, and I love it. And then then they come in here, and then they are putting in these very sophisticated vision systems to understand where the boxes are and the best way to pick them, make sure they don't collide. So, and you'll notice that when it goes around, it takes a picture of the environment. So it goes in there, it knows what's going on. So before the bot even turns, it knows where the box is. So the decision was already made before the box even started to move, because that vision system back there takes the picture and gets it. So that'll make it run really, really quickly. And it's, and it just pulls. It's great. It's really, but it's not what you expect from Boston Dynamics. You're expecting Atlas to do that, but they've been able to take their knowledge and expertise to be able to do that. And that's going to make them money. That's going to make them the money they need to stay in business to eventually perfect that. So all of them are facing the reality is like, okay, we need to start finding customers. And because the venture capital money is going to run out after a while, you need to find it. Agility is another one that is doing it, and that they have the digit bot. It doesn't have a fully formed hand. It has more of a flat palm, but it's very good at logistics inside of a factory and being able to move totes and everything else around. And it could also be, I wouldn't call it the last mile. They call it like, the last yards delivery of going up the steps, where you can have a bot that's very good. It's a very good walking bot, no doubt about it. Everyone will call that the ostrich because it looks like its knees are backwards. What you think are its knees are actually its ankles. And and then what you think of its hip is actually its knee up very, very high. So it's very stable. It's very fast. It can reach up very high, but it doesn't have the dexterity in hands to be able to assembly task. And they're like, yeah, it doesn't matter. There's all kinds of applications out there where people basically can do the whole job wearing a pair of mittens anyways. You don't have to have necessarily the fingers. So why put the complexity and the cost? And they set up the first humanoid bot factory. So they announced that, and with the idea that it can produce up to 10,000 bots per year. And that's very bullish for, let's say, this whole segment, because there's some other player out there that has actually gone to some of the big trade fairs, demonstrated it on the shop, on the floor, on the fairground floor of the bots going over and taking these totes off of shelving and putting it onto conveyors and then coming around, and some other bot picking it off there and putting it back up the shelving. So it's like this endless game of doing it. But it shows that it can do it in the utility. And clearly they get enough interest, enough orders from people to say, we think there's a demand out there for at least 10,000 of these bots per year for our bots in that logistics space. And that's good, because that means they're now going to get the cash flow to allow them to go on there. There's a lot of other players that have been announced that are going more towards, having dexterity in the hands, and others. I know there is Sanctuary up in Vancouver. I think in the Austin area, there's I think it's the Apollo robot from Aptronics. There's several over in China. Fourier is one, Unitree. And if you look over in China, and I think in Korea, there are a lot of these copies of the Boston Dynamics Dogbot.
Off the spot.
There's a lot of them, and they're doing flips, and they're doing some pretty wild things. And like some other one, I'm not sure who it is, that has basically a two-wheeled kind of delivery bot that is also really cool, because it's just so simple. It's able to fold up into all sorts of different configurations and move around and like go upstairs and over terrains that you're like, you can't do that with a bike. So it's like the mountain biking version of a wheeled bot. It's just crazy on what it can do. And the thing is, like, everyone's thinking outside the box what they can do, and realizing we can get these control systems that are really good at being able to do balance nowadays. So let's just come up with something wild. And you're going to see more and more of these different kind of bots out there. So the economics is starting to be real for some of these companies. For Tesla, it's not quite an issue, because they don't need to sell it at first. The long-term thesis is that if you want to say, oh, the stock's going to go to the moon, it goes to the moon because they start selling the Tesla bot. It helps the stock in, let's say, the medium term, when it starts helping with the margins. So when Tesla's able to reduce their internal labor costs, and now you get a bump to your margins, which could be a couple of percentage points or more, then Wall Street loves that. And then, of course, that's what makes the shares go up. So it's going to save Tesla potentially hundreds of millions, if not billions of dollars a year in labor costs by doing that. Outside, the numbers get kind of crazy, because if the Tesla bot can be produced for as cheaply as we think it is, Tesla has two models. One that they just sell it, leave all the money on the table, and the other is that they lease it for a certain rate per year, which is competitive to like the lowest wage earner in the company. The thing is, it can do 3 shifts, while that same wage earner could do 1. So right away, if you lease the Tesla bot for around $50,000 a year, that's about what it costs for minimum wage in the US. I don't know what it'd be in Germany, but I mean, we're talking, minimum wage. Yeah. When you get into the factory, it gets a bit higher. So already it's cheaper in 1 shift. So even if you bump the price of it up there, and then you start thinking about, well, that shift has to be manned round the clock, or at least 3 shifts somehow. So rather than looking at a labor cost at $70,000 a year to man that station for 1 shift for the entire year, 3 times that is suddenly, $210,000 per year for that one operation. And you're saying, yeah, Tesla bot could do that for $50,000. That's crazy. And so then it comes down to this idea of headcount, that it's not that the Tesla bot will be a 1-for-1 swap. It could be like a 3-for-1 swap right there when you start looking at 3 shifts. And then if you go to 4 shifts, then it gets even worse. The other possibility is that the Tesla bot could eventually have the efficiency that one Tesla bot can do the operations of 2 workers. At first, it's possible that it might only do the work of half a worker, and you need 2 of them. So if you get these examples of a worker that's responsible for 2 loading stations simultaneously, and if the Tesla bot's too slow, then you need 2 of them in there, manning 1 each. And then eventually it gets good enough that now it's there. But then what if the Tesla bot gets a little bit faster and says, well, I can man not just 2, but 3. So now it's 1.5 workers. And then you start multiplying it. And then so you don't look at it as like, okay, our company has a headcount of 20,000 workers. That means I need 20,000 Tesla bots. It might be, maybe only need 5,000 Tesla bots. So that's where the numbers get really kind of crazy on the economics, and very easy. You can see that, and everyone would shift. And it's not just in factory settings. Everyone keeps on pointing out, oh, could Tesla bot do something like that? It's like, oh yeah, it probably could. It's well within the realm of possibility. There are other jobs that are going to be more challenging. Everyone would like to say, can we have it do roofing? And it's like, that's probably going to be a hard one. We would love to see it do it, but it's pretty challenging. We're looking at things that are more, like they say, repetitive, boring, dangerous jobs. Yeah, the dangerous part is definitely working up on the roof, but the repetitive and boring is loading the same part again and again the whole day. Very, very simple, but repetitive and boring. Yeah, it can go ahead and do those things right away. Eventually, it gets into the higher skill stuff, but it's going to still be years away.
Yeah. Yeah, and I mean, for example, the Boston Dynamics bot that we've seen, for example, like with more of a crane, makes, for example, maybe more sense to do roofing, because it just can look at the roof and just put the tiles there and nail them down or something like this. I mean, a crane-style robot would make sense maybe there. I mean, of course, it's just a thinking game of what applications would we use, but humanoid robots, I think, have still their niche in what they do. They're very versatile where humans operate, but some tasks could be done by different robots. I mean,
and you could think of other things where it becomes a coworker. Agility is thinking more as a coworker to help side by side, not necessarily replace them, but maybe make them more efficient. Be like the Sorcerer's Apprentice, or become a gopher, just go and grab these things, or help me hold this thing because sometimes you need like 3 hands, right, to be able to do a particular task. So it may help out there. But I can also see it doing a lot of the setup and prep that sometimes slows down like construction sites, because the whole thing with the contractors is trying to get all these different crews to come in to do something. And if just one of them gets delayed behind, it screws up everything else. And those guys says, well, wait a minute, we got people next week, you're going to have to wait. And that just screws everything up. And a lot of times when you want to start to do a project, with painting a house, you might have these contractors that you say, set up the scaffolding. And then for some reason they don't show up that day, or they're busy somewhere else, or the scaffolding is over, whatever it is. But a lot of times it might just be a labor issue. And you could say, well, setting up that scaffolding, yeah, that's something the bots can do. So there's like a lot of this early prep work that they can go ahead and do it. And now the scaffolding's up there, now the craftsman can go up and do it. And then they're not breaking their backs setting up that scaffolding, because a lot of times there might be contractors that have to do that themselves. So I can see that there would be a lot of these worksite kind of things where, the jobs that no one is doing or backbreaking, a little bit dangerous, like it gets done, and it's going to get done. So because that bot army comes in right when it's supposed to come in, sets it up, and goes off. So that would be one area where I see it can be help overall productivity.
Yeah, and can you imagine deployment of those robots if we think about it? Like, I have the scene in my head that the Tesla cyber van, like the not announced van that is still in the works, that is coming there autonomously, opens up the side, and then like a special van or maybe a modified Tesla semi, and suddenly those rows of robots come out, and then they just start walking and run to the. It's crazy science fiction, but I think if you have a real application of a humanoid robot, I think Tesla will be like the first ones that will make it at a scale that the others don't, I think. Yeah.
Right. Now I think as promised, I think that we cover kind of all the topics except for my crazy Tesla bot factory.
Exactly. Yeah.
And what that's going to look like, because everyone is trying to figure out what the scale is going to be like, how Tesla is going to build the robots, what the cost is it going to be easy to build? And the overall question is, it is fairly easy to build. If you go out and actually look at one of the Opticons that's in the mall, you can see it doesn't have a whole lot of complexity. The main thing is there's certain components that need to be available. So you have like the servos and drives that are going to be there. So long as you have the different components, it'll almost, come together very quickly. You don't need any fancy drills or anything like that, or power tools or anything like that. Almost just the tools kits that IKEA gives you, you can probably assemble it with. But of course, what you need is those actuators or motors, which are going to be coming, going to be either part of that factory or coming from another factory. So they're ramping that up right now. That'll probably be traditionally produced. And then once you have that, you can just start assembling them together to build up your Tesla bot from all those different components that will be coming from a variety of different places. And that's what Elon has said, that they're getting ready to build that because they're finally happy with the design. He also says that they're tweaking the actuators and the mechanics a little bit. And so it's going to be interesting to see what they've decided to change and whether they're minor or major changes to it overall. But for the most part, it should be fairly simple to put together. And we've already seen in one of the Optimus videos sort of showing one Optimus putting together another one. And which means they're probably looking at what's going to be involved in building it in the first place, and is it something well within the capability of Optimus to do it? And I really think a lot of it is, and it's just going to get better and better over time. It's not like putting together a car. You don't have some of the involved steps that goes on with building a car, and the assembly line will be very simple. How much is it going to cost? My estimate is they should be able to build it for under $10,000. Their cost, maybe a little bit less. That doesn't include the cost, let's say, setting up the factory and everything else, which you have to amortize over a certain period of years. So it's not going to be like $100,000 product. It should be able to be less than that. So how do you put it together? You just set up your traditional sort of lines with all these places with workstations with people going in there and assembling these different things and then cobbling it all together. And then you think of the traditional assembly line, like, Henry Ford with something going on down there. And I was thinking, okay, we've got to break it down to different components. What's the major component going to be? And the very first one is going to be the central torso. So the torso is the structural battery pack. So the battery pack is in there, the electronics, everything else. And then, of course, the head with the cameras. So that's all one structure. And then you pop in two motors onto that thing, which are the first two motors of the shoulder that you actually can't see there. They're hidden behind the torso. You would have that, and then everything else gets built onto it. So the hips or the pelvic girdle would go on next. And then once you have that, you can then mount the legs onto the pelvis, and then of course the arms onto the shoulders. So once you have that torso assembled, where does it go? Does it go onto a conveyor system somewhere? Does it go into some overhead gantry where it's going to look like a meat hook, where this thing is just kind of going on down the line. And then someone goes up and attaches one limb here, another limb there. And that's one possibility. The other is that it might go into, rather than going onto a conveyor, because the problem with a conveyor is that everyone's sort of dependent upon the station before you can do something. And you like to uncouple it. And that's the whole idea of the unboxing process. Yeah. So we saw, the one example, I don't know if when you find it of the bots assembly, the other one is that one of the bots was lying on what looks like a table or a bed, or if you want to call it a gurney. Mm-hmm. So a gurney would basically just be a bed with wheels that you can start moving around like in the ambulance. So you either assemble it on something like that, or potentially you put it on like a small little scaffolding where you suspend it. And if you look at all the human bots that are being built in these labs everywhere, they're usually hanging it in some sort of frame that allows them to get access to everything, to maybe, make attachments, remove things, everything else. So you can imagine those things, and those things are usually on wheels. So, okay, I have one of those things up there. I assemble my torso, and now I just hang it in that scaffolding. Now, what do I do with that? Do I just kind of leave it there? Or maybe what I do is like, maybe the operations that have to be done here is done by a person, or maybe it's done by a bot. So the bot will go ahead and put it together. Now, the thing about the assembly line with Henry Ford, it was all about division of labor. Division of labor means everyone had one job and one job only, and you just did it, and you did very, very well, but you didn't kind of cross over and do anything else. Yeah. And the reason for that is because people were very good at concentrating on one particular job, but really bad at being able to do a long series of events through the whole thing, even though that would be less boring. So the way to get the high throughput is to have the people just doing the same thing, because once you're focused on it, you get into that zone, you're doing it again and again and again. If you have to do a different operation, a lot of times that takes your focus away, or you have to basically do kind of a mental setup and set down, or maybe you actually have to change something. You have to grab different tools or anything else. So that's how that was set up. But what I think you can do with the bots, because the bots can do any task that they want very quickly and not have to think about it. It's just, they could just do it, and they can do it just as well as any other bot. And even if they haven't done it for like a couple of days, they can still do it as if they had just done it a few minutes ago. So normally the human would hand it over to there, and someone else would worry about where that frame is going to go. But if it's a bot, the bot might put it on there and now push it over to somewhere else on an open floor for other bots to come in and continue the process on. Meanwhile, when that bot moves away from assembling the torso, another bot that just finished doing something else will slide in right behind him and start building the next one. And then you can have a sub-assembly of like all the other limbs going on there. And rather than when a limb is done being dropped onto a conveyor or dropped onto a mobile robot to take it down where it's supposed to go, once that bot's done building that thing, it just carries it down and then puts it right onto the torso. And then again, when it leaves its station, some other bot realizes that station is free. I'm going to come in and start working there. Now, what could end up happening is that and by having everything not on a conveyor system, but kind of broken around, let's say there's an issue with one of these torsos, that something's not quite working right. They're putting in there, they're noticing something, is having to run some self-diagnostics. If that was on an overhead conveyor, that would stop the flow right there. Like, we can't do anything right here. We're trying to advance. I just put the left arm, it's got to move up to the right arm station now. And I can't do it because this stupid torso is blocking it. By having everything unboxed like that, one of those failures does not take the whole thing down. And these things can be placed anywhere randomly in this open floor. You just push it to, right over there. And if you've ever been to like a hospital, sometimes that's exactly what it is. Like the gurneys is just kind of like wherever there's free space, boop, put it right there, wait for the doctor to come.
Here are the spare arms. New Tesla spare arms are here. And then they start
doing it. And you've got a bunch of Tesla bots that are working on left arms, and they start walking up the station and they're standing in a queue. And they're like, wait a minute, it looks like we got too many left arms. And then they're looking down there somewhere else. It's like, wait a minute. It's like, there's no one over there putting legs on. Why is no one putting their legs on? Oh, we don't have enough legs. So what they realize is that when they finally get that left arm on, they go over and they start building legs now because there's not enough legs. Or maybe it takes longer to produce legs than it does to produce arms. And so they will then start to sort of self-organize, and the system will self-balance on what it's supposed to do. And that is the dream of all the manufacturing engineers, because they simulate ahead of time to figure out how many stations they need, the layout of the conveyors. And if you get it wrong in the forecast and you go down there, it's not quite right. It's like now you're having to reroute conveyors, tear things up that you don't want to, add a new station that you thought you didn't need that turns out you do need. This way, by not having everything tied in there, no mobile robots, no conveyor systems, no dedicated area that you're building something in. Everything kind of moves around and they will self-organize eventually. They'll figure out, if we organize these workbenches over here instead, it's a lot quicker. No mobile robots for you to get tripped in, okay? Yeah. That means your lanes get narrower because a lot of times the access lanes, we've got to get our fork trucks got to be able to fit in here. So it's going to have a certain width and this and that. And the fire code demands this and that. It's like, no people in there, screw the fire code. We could just pack it in as tightly as you want. So you'll have all those things organizing. And this is basically what I call a sofa full of SOBs, which is a little bit of a joke, okay? So the sofa is a self-organizing factory automation. Mm-hmm. And the SOBs are the self-organizing bots. So that is pretty much what I think it's going to look like. A sofa full of SOBs. And they will just walk around, they'll figure it out. They'll realize that, hey, this particular part's taking a little bit longer. Let's throw more resources on it. Let's scale back the other until we get everything back into balance. Mm-hmm. And because nothing is sort of getting in anyone's way, if something needs to do rework somewhere, it just can get pushed off to somewhere else, or another technician can come in there to figure it out if the bots can't. And then eventually the bots will figure out what's the quickest way to put together a left leg or a right leg, kind of like what Jeff Lutz was saying. And once they figured that out, all the other bots will do it. So now suddenly that problem we're having that we couldn't make the legs as fast as the arms. Whoa, guess what? The arms are too slow now. Let's go over and figure that one out. It's just, so you could imagine this kind of thing where the factory is going to be different. The layout's going to be different. It's going to be so light. It's almost like, just get me the square footage. Just give me this big empty hall. Yeah. And I'll come in with the bots. And we'll have a few workstations and a couple of Black & Decker and Hilti tools for, here and there, what we need. And then just the equipment. And so they will become the mobile robots, which is, you don't do it with a human. It's wasteful to do it with a human. The human, you keep them there at the station and you don't have them carry the part over. It's something else. So you put in a robot, the automation. And I'm just looking at, maybe even the forklifts and all those other things you typically have would go away. They will figure out a way to move these things around because they are so cheap, they could be deployed for something and in applications that I thought would be wasteful for this type of automation. But it will be okay because what they'll do is they keep trading places. It's not like one of the bots is going to be the gopher the whole time. He's just filling in a hole. He's just like, there's a need here right now for this. I'm going to go ahead and do it. And then when I come back, I see, the torso workstation is free. I'm going to go over and start doing that right now.
Yeah, and not even that. I mean, I had Joe Justice on the channel as well, like a few months ago. And it was interesting, again, to hear it that this Tesla already has this self-management system that they have in the factory. And this is so interesting because when parts are missing or something isn't delivered on time, the factory floor actually changes and the worker gets a task like, this task is done, you have to do this task now. And that's the same thing. I could see that because the whole neural net intelligence, because it's an intelligent factory actually, almost like an entity, knowing what's happening all the time, but with no conscience, of course. We have to. Our fantasy has to go back again, back into the box, a little bit more rational with that topic for me, of course. And then, and then you have this deployment of, for example, the Tesla bot doesn't have to think about, no spare parts because the factory already knows and reorganizes it and gives them orders to go there that way. Yeah.
Yeah, and it could be that.
And that's already implemented. That's already functioning. That's a functioning thing that is already working at the Tesla factory. And everybody has this smartphone to get their new task, actually.
Which is why I think they're going to do this, because when I was going through my head and everything, I said, there's a little bit of deja vu and said, wait a minute, this sounds a little bit like the way Joe Justice explains how the Agile is working in there. And that's why I was like, they're probably really going to do this because it's just like that. So, a lot of it was from that episode of yours. I was thinking that at the same time, which is why I had more confidence. It's like, it's kind of like what Joe says. And sort of the difference in some of them is that you have somewhere that there may be the information that's sort of deciding that, there's a parts problem over here, but it's this big brain up there that may be aware of it. But all of the drones working down in there, the worker bees, aren't aware of it. They don't have the awareness. And it seems like it has to be something that's, controlled very high up. Whereas if the Optimi have like their own sort of sense of agency or intelligence, they're right there and they'll kind of notice the problem and they'll do it, which is what sort of happens in Tesla factory is that people are there and they notice there's a problem instantly. They don't have to wait to be told over the speakers by something like, oh, there's a problem over here in station 35. We need all hands on deck over there. It's just like, you just kind of notice either by looking at that system or you walk past it, someone's struggling, you jump in there. And so that's what I'm thinking is a lot of it might actually be more very decentralized kind of decision making made by them that somehow will bubble up so the overall system is happy that the KPIs are being met. But it could just be a wild ride looking for this, and that of all the things that Tesla manufactures, it's sort of one of the easier things in a way versus the car that it will be like a really good test, and especially when it's the bots building themselves. And, the bot's going to walk off the line, which is even great. It's better because normally when the product is done, then something has to come over to carry it off and, bag it and box it or do whatever. And pretty much it's going to come off the line and say, all right, what do you want me to do? I'm ready. It's like, no. You don't work here. You're going over there. So you're going to stand in that line to get into the cyber van to go wherever you're supposed to go now.
Yeah. Yeah, and I also think when you combine all those layers, we've talked about that last time also, that I find it so interesting when Tesla also solves their language model, or we were already speculating that they already use a language model inside of their factory, and I don't mean the language model translating inside of the Tesla bot to transition it to movement. I mean like real voice inputs to hear what the human is saying. And I think the acquisition of X is so important for this as well, because now they have a lot of data of people interacting with each other. It could understand maybe humor a bit or sarcasm, because humans are like that. So how do you define it? And I think it's going to be very interesting down the line what Tesla will come up with, especially with the voice inputs as well. And then we have a bot that is like can get commands, remembers who he was talking to, and maybe remembering the conversation as well, reacting to it. Hey, how are the kids, John, or something like this? I mean, that's just small talk, doesn't really make sense. But if you say like, go there, do this, make this task, and it's so interesting to see all those layers coming together in a whole factory setup in a system like this. So absolutely futuristic stuff happening here.
I can see this being something that Elon would like, because he complains about the fact that, if you look at the volume of how much work is actually being done in a factory, it's like 3% of the factory is where something actually gets done. The rest of it is just sort of empty space. And when you look at a microprocessor, there's a lot more because it's kind of packed in there. And a lot of it is the density issues you're dealing with, the fact that you have some of these big vehicles, you just have to make space for them. So you can't compact them, Also, local fire ordinances and everything else, the fact that people are going in there. But if you start getting rid of conveyors, because I don't know if I'd necessarily consider conveyor a useful process. I mean, it's a necessary evil to get something from one place to another. But a lot of times it just seems like, well, what's it doing when it's sitting on the conveyor? It's like it's doing not anything, it's commuting. It's really rare. Sometimes the conveyor will be used as a buffer, but you start having buffers, that's already admission that you've got inefficiency in your factory, because ideally you don't want to have big buffers, but sometimes you do. The part of it might be is if something has to cool down and it's going for a ride on the conveyor, and by the time it gets there, it's cooled down, that's something else. But when I look at these bottling factories, bottling factories are absolutely amazing. You look at the conveyors, you see all these bottles running around doing stuff like that. And it's like, wow, that's a great roller coaster for those bottles. But what's happening? It's just going this long ride. I don't see anything that's going on. The bottles are full. They're moving around here, going to somewhere. I don't see anything. Some cases maybe they're getting washed, or a few others, but there seems a lot of it that's just there because the way it's configured, we now have to get somewhere else. And we just have to take this long ride to get over to the other place we now need to be, and here and there. And so you build all this intense infrastructure that seems like it has absolutely no value add. Now, I know there'll be some people arguing out there saying, oh, I could play, they'll tell me, like, but in my soul as an engineer, it's like nothing's being done there. It's this unnecessary evil of getting the part from here to there. And I understand, physics and the reality, you can only take up so much room with stuff like that. And you need all this, that's just how it's going to be. But if you could find a way to eliminate or get rid of that, you would have a far more efficient process. So if you can get rid of conveyors and mobile robots and all the infrastructure that goes with them, and just have Optimus do those roles for them, and also the self-balancing, that let's not have a backup buffer of like 100 left arms that aren't going onto torsos. Yeah. Why are we producing arms? We shouldn't be producing arms if we don't have enough torsos. So stop producing the arms and go over and start doing the torsos, or maybe set it up that you can produce torsos on the same workbench that you're producing the left arms, and just stop doing that. And then let's start getting caught up there. So the whole idea is the system should balance out.
Yeah, totally makes sense. Yeah, it's absolutely astonishing. And you also mean, but just for clarification, with the conveyor belts inside of the factory, you also mean those robots driving around with the cars on top?
Yes. So you've got your normal conveyor systems like you see at the supermarket, like, the Aldi checkout line. And then you have like the mobile robots, which just drive around and basically they're moving goods around. I think, the way to look at it is, I see like a conveyor as either like a railroad or a bridge. And sometimes to get from one shoreline to another, you can build a bridge to get things across there, or you can have a ferry that takes you from one place to another. And a mobile robot's like a ferry. Or if you want to think of it as like a bus. And, the advantage of a bus system is it's very easy to reorganize a bus system in a city. You just use the streets wherever you want. You can change the destinations like that. With a railroad, it's like, nope, we've got to move the tracks or build new tracks. It's very expensive. And of course, railroads are very intrusive, that once you kind of put them up there, they cut the city in half, and you've got to have a tunnel or a bridge to get over the railroad and all that. So when you put a conveyor system in a factory, it cuts the factory in half. And you got to figure out how to get from one side of the conveyor to another, unless it's a high conveyor. And a lot of times people have to either walk around, or you need to literally have a bridge in your conveyor, or you have these steps that allow you to walk up and over. So, all these things that just kind of complicate it, that you're like, get rid of the conveyors. If there's another way to shuttle the stuff around that you need to do. So it's not going to work in all factory settings, but there could be a lot. And when I'm looking at Optimus, I think they could do it without any of the traditional sort of pieces of equipment that you see in a factory, and just assemble it that way. And that's what I would go with, is just really try. And it seems close to the unboxing process as well. That's true. I think your theory is pretty interesting, and I hope you're right with that one. So you've heard it here, not first, but also in depth. You can also watch the episode with Herbert Ong, the interview. I highly recommend watching every interview with Scott Walter really much, because he's full of knowledge, and I really enjoy having you on always. And I think for the end of the episode, maybe we can look at the outlook that TeslaBot is doing in comparison, or how it's going to change labor in the broader sense, because we have those UAW strikes now. And how do you see the future in that sense, that because you're from robotics, and of course robotics maybe can of course replace the worker, and TeslaBot is one of those stepping stones. And now we have workers demanding more and more with those strikes, for example, and now we have companies thinking, the workers are kind of a problem. How are we going to solve that? More and more, and I don't know. You're going to.
What's your outlook?
Yeah, you always see more automation. Anyways, there's always needs to be this push for more efficiency, and I know there's great concern that it's going to put people out of work, but there's a lot of other people that are thinking the other way, that not necessarily it's going to allow other things, and we certainly have examples in history where we can see it turned out to not be as bad as you would have thought of if you forecast it. So the first thing is it's not getting rid of work, it's getting rid of toil. So toil is very difficult work that no one really wants to do. It's just boring, it's back aching, it's not a career, it's just something that kind of has to get done. It'd be nice to have something else to do it. So that's really what I see it doing, is going in, is getting rid of those kind of jobs and allowing people to do work they actually enjoy. And if you look through history, I mean, one argument is like, okay, so I sort of said TeslaBot could just end up replacing a lot of workers, or it could just make the workers you have more efficient. So I've got a company with 10 workers and I can bring the Tesla bot in and maybe fire all those workers. Or maybe I bring the Tesla bot in and like all my workers are suddenly way more efficient.
Yeah, and expand
and
the
as
factory,
a result,
actually,
I'm getting more output. And then it's so good, I decide I want to hire a couple more workers. Then there's my competitor who is not doing it. So they're sitting over there, and that if maybe for some reason I let go a few of my people, they pick them up because they're trying to do whatever they can to kind of keep up with me, but they can't. So eventually you get that competitive imbalance. So in one case, it might be kind of a day of reckoning for someone else, and the others, they're able to get a little bit better. And if we take it to like a real analogy like that, is that when the plow was invented, it made farming a lot easier for a lot of people. So just imagine you get these two farmers and they have all these workers, and all these workers just have these sticks that they're going through to try to do it. And suddenly invents the plow. And now what's he going to do? He could just say, I'm firing all those workers with the sticks and just going with the plow, and that's it. And they go over to the other guy who also is just kind of doing it that way. And the reason I have to go over there is because of my plow. I'm so efficient. And now in order for him to be competitive with me, he needs like the more workers to do it. The other is I can say, wait a minute, all my workers with the sticks, I'm going to give them all plows right now. And now I'm going to become super efficient. And then of course, what may end up happening is it causes maybe the competitors to go a little bit out of business, but it's going to be a slow transition. It's Tesla Bot's not going to do every job tomorrow when it comes. It's going to do a few here and there. Like I say, it's going to replace the jobs that people don't want to do and that they can't staff. And again, if you read Walter Isaacson's book, Franz mentions that they have staffing problems, and there are these jobs that people don't want to do. We can't kind of keep them in. So the Tesla Bot's going to do that to make sure it's always staffed and they don't have all the HR headaches of having to hire again, bring these people in, and then after a month they're bored and they leave.
And they know,
it's like, oh, that's done. And I think it was the same in Europe, but in the US 200 years ago, 98% of the population were farmers. Only 2% were like, artisans and, other craftsmen and stuff like that. And that shifted to now it's like 2% of the U.S. population is considered farmers and 98% is something else.
But
we're not on UBI or anything else. We've found other occupations, other things to do that mankind has always yearned and wanted to do. The problem is putting food on the table. Well, it's like, if you got to do that before you can even think of doing anything else. So if you want to be a playwright or something like that, you got to figure out how to eat. And if eat means you have to be a farmer, but if suddenly some technology comes along that makes it a lot easier, wow, now I could be a playwright, follow my passion, and entertain the farmers at night. So they kind of have something to look forward to at the end of their hard day. So, that's the whole thing that's kind of going on, is the economies will be able to figure out, people will become a bit more creative. So I think I'm listening to both arguments. It's not like I'm coming down as it's this or the other, because I think the dialogue needs to be now, and we need to understand it, because there's sort of one of two things we can do. We could just sit by and let the train wreck happen and then just see whatever it is. The other is we can start looking at the various scenarios. And as you look at those various scenarios, think about how can we help shepherd those things so we get the positive output we want, rather than just accepting whatever happens. And, I'm well aware that there will be societal disruptions as a result of this. But it's going to happen anyways. It's always happened. We've had industrial revolutions constantly. The industrial robot that's out there right now, everyone says it's going to take everyone's jobs away. It's like, no, it took away certain jobs, but they still need all these other jobs where the people are there. Some people say it actually made better jobs, because now you need robot programmers and the people that set them up and tend them and maintain it. So it was a lot better than being the spot welder. So it's going to change, and we just have to make sure that it's not such a rapid disruptive change that you do have societal disruption. I just wanted to touch on one thing before we move over, because I think you've made an interesting point here. If you have to think about air, water, food, shelter, sleep, clothing, or reproduction, then you can't really go to the next phase, which is when those needs are met. Then you have safety needs, for example, personal security, employment, resources, health, property, maybe, and then love and belongings, and so on and so on. So if those like steps are made, then you actually go towards the self-recognition, freedom, or maybe even art, for example, and stuff like this. And if you're just struggling with food and shelter, you cannot think about these things. And that's how society also changes. That we have different people in different areas of the hierarchy. Just wanted to touch on this, but
it's a rapid change we were witnessing, and Tesla is one big company also shifting there. So thanks a lot, Scott, for being on. I think that's a good point to maybe end the episode here. I also want to reference my Tesla weekend here because that's where I took the footage of the tour of the Tesla Bot as well, and also Scott did some shots here and there. So I'm going to link everything down below, of course, and please follow Scott, of course, on his social media. And he always makes interesting posts, recently liked by Elon, for example, the last fun one he did. So check him out on X especially. So there's only one last thing that we both can say to the audience, and that's goodbye, everybody.
Yep, and tschüss zusammen.
Ciao zusammen.
Wasn't this episode awesome? Let's accelerate the pace of innovation by subscribing to TeslaFix. This is my absolute favorite channel on the whole interwebs.